Okay, so we were talking about metals in the previous class. So today we are moving toward extraction of aluminum metal, right? Today we are moving towards extraction of aluminum metal, right? As I have told you that the reactivity series is very important. So you need to remember this. It will help you out in many things, just like this. For example, I'm just writing the reactivity series over here. So it will be like this. Reactivity series I'm writing over here, right? And I have told you that reactivity series is what? Potassium, sodium, calcium, and then metal. Metal means magnesium, aluminum, zinc, iron, and lead. And then we have copper, silver, gold. Right, so you need to remember this. We can place carbon over here, we can place hydrogen over here, just because of it that they both can form positive ions, right? Then I have told you earlier that the elements that are more reactive than carbon can only be extracted by okay, so sorry, there is interruption. So it is more reactive, and they are more reactive than carbon. So the only possibility to extract them is electrolysis, right? Electrolysis of their molten salts, electrolysis of their molten salts. And I have told you that already, that we have one example over here, that in our syllabus, which is extraction of aluminum from its ore, right? So right now we have what? Right now we have ore of aluminum here, which is known as aluminum oxide. This is the ore of aluminum. The name of this ore is bauxite. G.
सर आपने स्क्रीन शेयरिंग नहीं ऑन की हुई?
नहीं की हुई? पहले बता दे यार. सारी मेहनत जाया हो गई. Okay, no issue. Let's start again. I am telling that you can see over here. Let me remove the above one. Okay, so I have told you that we were talking about what? Metals, and today our topic is what? Our topic is extraction of aluminum metal, right? So you can see over here, this is the apparatus by which we can extract aluminum, right? But before going towards this, we need to understand this what? Reactivity series. You can see over here, this is the reactivity series: potassium, sodium, calcium, magnesium, and we can use metal word: magnesium, aluminum, zinc, iron, lead, and then copper, silver, gold. We can use carbon and hydrogen over here, just because these two elements can form positive ions, right? And I have told you earlier that the elements that are more reactive than carbon, वो सारे elements जो के कार्बन से ज्यादा reactive हैं, they can only extract by electrolysis, and especially electrolysis of their molten salts, right? Now you can also extract them by electrolysis, but aqueous solution can also be electrolyzed to give them these salts, because they are less reactive than hydrogen. Electrolysis of their aqueous salts. But actually we are talking about right now extraction, not purification. So these need to be extracted more easily with like carbon and hydrogen elements. So these processes are cheap, so we can use that one. But right now electrolysis is a very you can say that it is costly process. So that is why we just try to omit this, right? So we can only extract highly reactive metals by electrolysis. So it is the condition to use this. So other than this process, we are not able to use any other process to extract them out. So that is why we are proceeding electrolysis for the initial 5 metals that are highly reactive. So here we have the apparatus for aluminum. You can see over here. This is extraction of aluminum. This is the apparatus for this, and it is a special case, and this is the special apparatus for this. You can see over here. Now, here we have what? Aluminum oxide. You can see that Al2O3. Bauxite, the name of this ore. जब हम इसको जमीन से निकालेंगे तो उस जमीन के पोर्शन को हम बॉक्साइड इसलिए बोलेंगे बिकॉज़ उसके अंदर एल्युमिनियम होगा और ये वाला एल्युमिनियम होगा Al2O3 वाला. Now, one more thing for your information. For example, if you talk about NaCl, so Na is positive and Cl is negative. And if you talk about NaCl structure, it is just like this. This is the crystal letters of NaCl, right? And each positive is attracted by 6 negatives, right? You can see over here in this way. So each positive is attracted by 6 negatives, right? And every single negative is attracted by 6 positive as well. So you can see over here and you can imagine that how strong that structure of ionic compound is. So they have high melting point, and you can imagine the boiling point and melting point of this. And I have told you that the melting point of NaCl is nearly 800 degrees centigrade. So if the charge is doubled, right, like magnesium +2 and oxygen is -2, magnesium oxide. So you can imagine that how the melting point of this compound will be. It is definitely more than 800. And then definitely if we increase more charges, so the melting point also increase, right? So you can imagine that the melting point of aluminum oxide is too high. Melting point of aluminum is too high, right? So when the melting point is too high, so we require more energy to break them out, to just overcome the energy between, to overcome the bond energy between like aluminum and oxygen. So we require a lot of energy, like and it will cost, right? When the energy will be consumed, definitely there is a too much cost as well. So that is why we are using one more thing along with aluminum oxide. The name of this is cryolite, right? We are using cryolite along with aluminum oxide over here because it reduces the melting point. It reduces the melting point of what? Al2O3. Ultimately, it is what? Reducing the cost. Ultimately, it is reducing the cost as well. Reducing the cost as well. So you can use both purpose of this, right? So we are using cryolite and aluminum oxide together over here, right? We are using aluminum oxide in molten state and along with cryolite. Why we are using cryolite, Asna? Yes, Asna, can you hear me?
Yes.
Yes, why are we using cryolite over here?
Because of the melting point.
Exactly, we want to reduce the melting point so we can save the cost of the process, right? Good. Now you can see over here why I just leave the place over here in the bottom of the beaker, or you can see that in the container. Now, first of all, you need to understand this, that this is the negative charge of the battery. So that means the bottom area, negative is cathode, right? So the bottom area is what? Cathode. It is the cathode area, right? And it is a positive charge. So you can see that these 3 blocks that we just hang in the container, these are positive is anode. So they are anodes, right? Now, anode is made up of carbon, or you can say that it is made up of graphite also. You can use this term as well. Anode is made up of graphite or carbon, and cathode is made up of steel, right? So when we pass electricity through the solution, so what happened? We know that at cathode, it is what? Cathode is actually negative part of this cell. So it attracts all the positive ions. So when aluminum attracted towards cathode, and it just gain electrons over there and forming aluminum in liquid state. Right, bacho? Aluminum is silver in color, so we can just draw in this way, right? We know that aluminum is metal, so it is highly dense than the solution, so it start collecting in the bottom, right, bacho?
Yes.
Now, one more thing. For example, if you talk about anode, so at anode, we have oxide ion over here. So it loses electrons, right? It loses electrons and form oxygen gas. Now, oxygen is O2. So for this, we require two oxides. So when one oxide loses two electrons, so definitely two oxide loses four electrons. So we need to write it correctly that for two oxide, it will lose four electrons. So this is the equation. Initially, it is liquid, and after that, it is gaseous. So you can see over here, the gas will release from here, which is an oxygen gas, right? From here, there's a release oxygen gas, right? So it is a oxygen gas. Okay, bacho? Now, one more thing. We have a high temperature over here. We have high temperature over here, right? And anodes are carbon. Anode is of carbon, right? And carbon is what? Carbon is actually non-metal. So it can react with oxygen. So there may be a reaction between carbon and oxygen. So it can form carbon dioxide and it can form carbon monoxide as well. So these two are other possible products. These two are other possible products at anode. At anode. So you need to remember this. These gases can also be formed at anode just because of this, that carbon is also reactive, oxygen is also highly reactive, and the temperature is too high over there just to melt aluminum oxide. So there may be a reaction. So that is why we need to change carbon anodes after a few times. Okay, bacho? Okay, bacho.
Yes, sir.
Now you need to take a picture of this. It is very important. I just draw this picture for all of you guys so you can draw. Take a picture of this. Done? You can take a whole picture so it will give you the notes of this topic as well. This is a very important topic. This is the part of electrolysis and this is the part of metals, extraction of metals as well, right? Okay, Hamza, is that done?
Yes, sir. Done.
Okay, so this is the extraction of metal that is in our syllabus. I have told you two of these. One is like blast furnace, and the second one is this. And I have told you in the previous class as well. If you see the reactivity says that iron is extracted from blast furnace because it is less reactive than carbon, so we can reduce it by carbon. Reduced by carbon. Even all of them that are low than carbon, they all can reduce in the presence of carbon, right? But one more thing, one is you can see over here, they are also can reduced by hydrogen as well. And we have one more example of this, right? Let's solve this example. If you move towards this example, so it is just like this. For example, the example is just like this. Here we have a test tube, right? And in this test tube, we are just going to add hydrogen gas, and this test tube is closed from here, right? And it is open from here, right? And it is just like this, and we are just using copper oxide over here. It is copper oxide. This one is copper to oxide, right? You can use the word copper to oxide over here. This is copper oxide, and we are heating it. We are heating it, and we are passing hydrogen gas from here. We are passing hydrogen gas through it. Okay, bacho. Now you know this. You know this, bacho, that initially oxygen will remain from here, remain just when hydrogen enters the tube, so it will emit out oxygen, nitrogen, whatever the percentage of air inside the tube, so it will get it out, right? And then what's going to be happen over there? You know that copper oxide reacting hydrogen is more reactive than copper, so it will displace copper and take the oxygen towards itself. Okay, but so this is the reaction that is going to be happen over here. Now after few time, you will see that water molecules eliminate from here. This is the most important reaction you need to remember. Okay, and definitely when all the copper is reduced, it is the reduction, removal of oxygen. When all the copper reduced, when just copper become a single, or just it become alone, so we need to turn off the heater, right? When we need when we just turn off the heater, so we know that what's going to be happen, by and by the copper which is in hot condition is going to be cool, right? But बच्चों ये आपने याद रखना है, जब आप हीटर बंद कर दोगे तो कॉपर जो होगा वो गर्म हो रहा होगा, ठीक है? तो आपने हाइड्रोजन को पास करते रहना है. We need to pass hydrogen through the tube until and unless copper become cool. जब तक कॉपर कूल नहीं हो जाएगा, हम उसके अंदर से हाइड्रोजन पास करते रहेंगे. और उसकी वजह क्या है बच्चों? We know that when the copper is hot, if we just stop passing hydrogen gas from the tube, so it will just it's just going to allow oxygen to enter the tube. Definitely air is going to be enter, and in the air 20% is oxygen over there, so oxygen is going to be enter into the tube. And when copper is hot, so it can react with oxygen as well, and it again form what? Copper oxide. So just to avoid this reaction, we are just going to stop heating and just allowing copper to cool down, and till that time we are just going to pass hydrogen through the tube. So in this way oxygen is not going to be enter in the tube, and there is no reaction with oxygen and copper, right bacho?
Yes.
So this is the reduction of hydrogen, reduction of copper oxide by hydrogen. So you need to take a picture of this as well. It is also important. Just take a picture of this as well. No, well, wait a minute. I just need to write, keep passing hydrogen gas through the tube until copper become cool, just to avoid reaction of hot copper with air, right? But now you can take the picture. It is a key point for MCQ. It's going to be oxidized. Done, Macho?
Yes.
Okay, that's good. So let's move towards some MCQs, right? Let's check a few MCQs. Let me send. Okay. There is a little bit issue with that. I don't understand why it is not standing, but I am trying. We need to try all the time. It's an important thing. There is job. Uh, so I don't know what is the problem over here, but it's not standing. So I will show you some past papers question. It is important, but right now it is causing a issue over here. So let's move towards some other past papers question that is from the row paper, right? So we can follow through it. I have a lot of past papers that I create myself, and I just collect through 20 years, but it is a problem over here. So let's see from here. Extraction of metal. Let's check. Yes, which oxide can be reduced to metal by hydrogen? That's the first question that I have told you just now. Yes, Hamza, can you please answer this? Which oxide can be reduced by the metal or to the metal by hydrogen?
Sir, copper 2 oxide.
Copper to oxide. Very good. Why there is any reason?
Sir, it reacts with the hydrogen and it's a reduction reaction. So H2O is formed and then in the tube only copper is left.
Yes, and the reason is it is less reactive. Hello, bachcho. Can you hear me?
Yes, sir.
Okay, sorry, there is an interruption due to the Zoom application. So, yes. So I am asking about this question. Asna, can you hear me? Yes, Hamza, can you hear me? Is that are you there?
Yes, sir. Your voice is audible.
Okay. So can you please tell me the answer of this, Fazar? The answer of second question, it is related to sacrificial protection. So can you please answer it? The answer is what? Answer is A. Why? Because magnesium reacts in preference to the iron. Because magnesium is more reactive, so it will react first and iron will not, right? So if you're not able to answer, so you can check this now. Yes, this one. Okay. Can you answer, Hamza?
Sir, aluminum oxide is solid, and then after, and the aluminum will be liquid.
Both are liquid, beta. Why aluminum oxide will be a solid? We know that solid ionic compounds cannot conduct electricity. It should be liquid or molten, right? So
Yes,
both
sir.
are liquid. So the right answer is A. Let's move towards this. Yes, iron is extracted in the blast furnace using the raw material hematite, coke, and limestone. Yes, which substance undergo the thermal decomposition? Yes. Fezar, किसकी होती है thermal decomposition बेटे? थर्मल डिकम्पोजिशन कौन से वाले रिएक्टेंट की होती है? Hamza, can you please tell me?
Sir, thermal decomposition. Sir, is it
We are heating calcium carbonate, limestone, CaCO3, heating that, and it is forming calcium oxide and carbon dioxide.
yes, sir. So it will be for limestone.
Yes, it is A. That is why I just write the definitions, or you can say that the heading on the top of the reaction, so we can understand that. ब्लास्ट फर्नेस में दो रिड्यूसिंग एजेंट मैंने कौन से बताए थे आपको? एक तो कार्बन मोनोऑक्साइड ही है, राइट, जो कि आयरन हेमाटाइट को जो है रिड्यूस्ड कर रहा है. दूसरा कौन सा था? कार्बन था, जो कि कार्बन डाइऑक्साइड को रिड्यूस करके कार्बन मोनोऑक्साइड बना रहा था. तो ये दो रिड्यूसिंग एजेंट है हमारे पूरे स्लेब, पूरे 5 इक्वेशंस में. ठीक है. So these type of questions are there in paper. You can see over here again. It is a very important part of MCQs and question answers. You can see over here in the manufacturing of iron using blast furnace, which reaction generate heats. I have told you the combustion of fuel. It is the question. It is the C. In the extraction of iron, carbon monoxide act as reducing agent. I have told you, right? And extraction, not redox reaction. It is part A, which is not a redox reaction. Then just such type of questions are there many times. Which statement about iron and its manufacture is not true? iron ore is readily abundant? No, it is highly available in the whole land, and it is continuous process. Pure iron is produced. The reducing agent is cheap. So you can say that the right answer is C. Pure iron is produced. Sorry, it is not correct because उसके अंदर मिक्सचर होता है. ठीक है, इस तरह के सारे एमसीक्यूज यहाँ पर मौजूद हैं जो कि आपको सॉल्व करने आने चाहिए. तो जो मैंने आपको पढ़ाया है वो आप सब कुछ इसके अंदर डील कर सकते हैं एंड इट विल गिव यू. देखें न्यूट्रलाइजेशन रिएक्शन कौन सा है, ये भी मैंने आपको बताया था, इट इज सी. ठीक है, इस तरह के सारे चीजें मैंने वहां लिखवा दी हैं आपको, तो ये सारे सवाल आप सॉल्व कर सकते हो. ठीक है बच्चों, इज दैट क्लियर बच्चों?
Yes, sir.
ओके, सो आप लोग इसको सॉल्व करो. मैं आपको रिकॉर्डिंग इंशाल्लाह भेज दूंगा रात तक या कल भेज दूंगा, तो आप लोग उसको जो है नोट्स भी बना लेना. ठीक है बच्चों, इंशाल्लाह नेक्स्ट मंडे को मिलेंगे. अपना ख्याल रखिए. अल्लाह हाफिज.
Allah Hafiz, sir.